Hello everyone, welcome to the session. In this session, I'm going to discuss about the one of the most important characterization technique for nanostructures, that is scanning electron microscopy, and the short abbreviation is SEM. In this video, I'm going to discuss about the introduction, principle related to the SEM and working mechanism, and the application. In addition to this, I'm also going to discuss about the advantage and disadvantage related to the scanning electron microscopy characterization technique. Here, this is the instrument diagram. This diagram is the complete instrument diagram. This is the setup related to the scanning electron microscope, and these are the monitors to observe the captured image. Coming to the scanning electron microscopy, initially we should understand why we are using scanning electron microscopy. What is the methodology incorporate in the SEM, and how we can analyze the captured images, topography images related to the nanostructures. The short abbreviation, scanning electron microscopy. Here, the name itself, here it is electron microscopy. That is, there is some difference between the optical microscopy and electron microscopy. As we know that optical microscope use the light as the source, whereas electron microscope, electrons act as the source to see the image. So the difference between the optical microscope and electron microscope is the source, that is light versus electrons. And result point of view, in optical microscope we can able to see clearly up to 300 to 400 nanometer resolution, but whereas in case of electron microscope we can go up to 1 nanometer. That is one of the advantage to utilize this technique to characterize the nanomaterials. As discussed, electron used as the source in SEM. And imaging technique, it gets the surface morphology of the sample, and the principle involved, how we can get the image. So the high focused electrons scans the surface, that gives the topography of the surface. Higher resolution till nanometer scale and greater magnification images are possible as compared to the existing light microscope. In addition to this, one of the most important feature is there is a possibility to analyze the elements present within the sample. So this technique is useful to understand the different nanostructures. Coming to the just comparison point of view, I just taken the previous discussed XRD versus SEM. Here XRD is the one of the characterization tool which is used for material science characterization or the materials characterization to understand the structural properties. But SEM is related to the morphological properties like size, shape, like is there any porous present or cracks present on the sample's surface. That complete information is given by the morphological image. This is the SEM image, and this is related to the XRD pattern. Both characterization techniques are completely different. One is related to the structural properties and other is related to the morphological properties. And here what we discussed in the principal point of view, high focused electrons scans the surface and the result is gives like a topographical image. But here high focused electrons is interact with the surface of the sample to get the image in case of SEM. So we have a doubt, what kind of role of electrons takes place in taking the image by SEM. Any guess? Any guess? What happens when electrons interact with the matter? So curious about this. What happens once the electrons interact with the matter like specimen? Here is the answer. See here, this is the sample. This is the top surface and this is the bottom surface. This yellow color is the incident electron. Once high energy electron reach the sample or interact with the sample, several electron and X-ray signals are generated. So we need to understand this. Once the electron beam strikes or they interact with the sample, there are several mechanisms involved. So for example, here the Auger electrons are released. Once it interact with the topmost layer and secondary electrons, backscattered electrons, X-rays and cathodoluminescence rays can be released in the point of above, like a reflection point of view. And below point of view, there is a possibility of inelastic scattering, elastic scattering, incoherent elastic scattering rays, and transmitted electrons. If the electrons pass through the sample, these electrons are called as transmitted electrons. So this transmitted electrons nature is useful to understand the TEM image. That is, TEM principle works based on the transmitted electron, but in case of scanning electron microscope, we consider the secondary electrons and backscattered electrons and X-rays. So these three are useful to get the complete characterization related to the particular surface. Coming to these are the general mechanism how these electrons are released or how X-rays are released. For example, in case of secondary electron point of view. So this is the material, the specimen, is the nucleus and electrons are located around the nucleus. Once the high energy electron strikes the material, the material loses its electron by inelastic collision. So this is taken as the secondary electrons. Whereas in case of backscattered electron, it is a elastic collision. Incident electron transfer the energy and electron is released. So this is the backscattered electrons. But where X-rays are used to understand the elemental composition related to the samples. So that X-rays can be generated. For example, this is incident electron. It strikes the lowest orbit electron, then electron is released. So to fill this vacancy, higher energy electrons or a higher orbit electron come and it place in the lowest orbit. Higher energy to the lower energy, the electron transition takes place. That transition releases the energy in the form of waves, that is X-rays. Here the secondary electron, backscattered electron and the X-rays are used to understand the sample behavior with the help of scanning electron microscopy. Other mechanisms are used for other characterization. Here, just small recap here, the secondary electron. These electrons are the reason for getting the sample's topographic, that is surface information is obtained by using the secondary electrons collection. These are very sensitive to the surface. These come from within a few nanometers of the sample surface. They originate from the sample atom and are the result of inelastic interaction. It's not elastic, inelastic interaction between the electron beam and the sample. Less energy compared to the backscattered electron. Then obviously when we're taking the backscattered electron, it is high energy as compared to the secondary electrons, and they provide the compositional information and low resolution images. Here it is the completely surface information with high resolution. So then obviously in case of SEM, mostly we are depending on the secondary electron collection. And this backscattered electron originate deep within the sample. Here it is the topmost layer, like a few nanometers, but it is few microns below the surface and interact strongly with the sample. Backscattered electrons are reflected after elastic interaction between the beam and the sample. Here it is the inelastic interaction takes place. This already we have discussed in the previous slide. See here, why secondary electrons are preferable as compared to the backscattered electrons in taking the image. As just we discussed about the BSE and SE, the basic origin, SE originate from the surface region and BSE originate from the deeper regions of the sample. Then obviously, if you want to study the surface related property, secondary electrons are preferable. And BSE is different for different atomic number samples. For example, high atomic number, the brighter image it appears as compared to the lower atomic number. SE, that is secondary electron imaging, can provide more detailed surface information compared to the backscattered electrons. So in taking the SEM, we are collecting the secondary electrons to obtain the complete information related to the surface. For example, here as discussed, BSE, that is backscattered electrons, is the change for different samples. Here they are copper and aluminum. Aluminum is the low atomic number as compared to the copper. Because of that, the copper getting like a brighter image as compared to the aluminum. This is because of BSE depends on atomic number. And this is the general origin between the SE and BSE. So SE image is always a high resolution image of a material surface topography. The surface topography of materials include fine structures like crack, pore, peaks and valleys. All this kind of information will be provided by the collection related to the secondary electrons. And X-rays are produced. As discussed, X-rays are produced when electron hit the sample surface. They give information about the elemental composition, like how many elements are present, how much concentration of each element present within the sample. That part also we can get by using the SEM study. So this is a general overview of a material in which area is need to be scanned to get the different images. So this is the sample surface. These the electrons are hit with the sample. 0.5 to 5 nanometers is mostly related to the agar electron. We are not collecting that. But 5 to 50 nanometer range, that is in depth point of view, 5 to 50 nanometer secondary electron emission can be taken place. This part we are concentrating to get the topography image of the sample. And SEM area, it is related to the backscattered electrons up to 450 nanometers, but EDS, like X-rays point of view, it is lower than that. That is micrometer range. That means electrons are deeply inject to get the to generate the X-rays to understand the what are the elements present within the sample. So these are the different regions to obtain the different kind of information related to the sample. Even the same sample, if you want to get the surface image or if you want to observe the elements present within the sample, the focus area is not same, like a depth area is not same. So this, like a upper portion is related to the topography image or the scanning point of view, and the deeper area is related to the elements present within the sample. And each and every element is unique. One element characteristic peak is not related to the other element. Because of this, EDS gives the complete information related to the different elements present within the sample. And coming to the instrument point of view, this is the instrument. This instrument consists of different components like electron gun, anode, condenser lens, object lens, sample, and secondary electron detector. Because we want to get the topography of the sample surface, so then obviously we need to collect the secondary electron. That's what we are taking, the secondary electron detector. And again, just observe, here it is the electron gun, anode, condenser lens, objective lens, sample or the specimen, and it's the base, and secondary electron detector. It is one of the very simple methodology. So, but each and every component role in getting the image we should understand. For example, electron gun. As we know that electron gun is the source to create the electrons. Is it right or not? Electron gun is nothing but it is generating the electrons, because we are taking the SEM as the standard form electron microscopy, electrons as a source, but source is given by the electron. Source is electrons is given by the source. Here the electron gun is act like a source, and it involves the thermionic emission. Generally, that is filament gets heated to the above 2000 degrees centigrade to release the electrons. This is about the electron gun. The role of electron gun is only generate the electrons. And now electrons are moving in as a beam. Electrons are moving towards the sample. In the process of sending sample electrons to the sample, here we are using the anode. As we know that anode gives the enough voltage to the released electron by the electron gun, because electron gun release the electron, it may not have that much energy. So anode gives the acceleration to the electrons by passing it in a accelerated voltage. So anode provides the sufficient energy to the electrons. And coming to the condenser, as we know that condenser lens condense into a particular fine beam. So condense, here we are taking the electrons are moving in different directions and it direct to the sample. The condenser lens role is it gives the fine direction towards the sample. So the intensity here in the condenser lens, the intensity, how many number of electrons are moving, and convergence, how much and how much area it need to cover, that all part is controlled by the condenser lens. So low energy beam, for example, low current beam, number of electrons are less, is used for the surface sensitive imaging. Higher beam, high number of electrons pumping is to characterize the element composition. Only surface point of view, lower beam will be useful, and a higher beam, that is high intense beam, is useful to analyze the elemental composition. Here electron gun is the source, anode gives the accelerating voltage to the electron, that is enough kinetic energy. Condenser lens, it directs the electron beam towards the sample. Next and most important is objective lens, which is used where it need to focus. That is, objective lens guides the electrons where it need to focus. See here, it focuses the beam onto the sample surface. It determines the final spot where it need to detect. So the position and strength of the objective lens influence the magnification of the image, whether it need to cover the 200 nanometers or the 1000 nanometers or the 2 micrometer. That is decided by the objective lens. Adjustment to the lens, either that means like in camera we can take it as like image by zoom in, zoom out. Similarly, we can get the image like a zoom in or zoom out. So the objective lens setup determines the working distance, because working distance means the distance between the objective lens and the stage. If the distance is more, it covers more area, less resolution can be possible. If the distance is closer, it covers only limited portion, resolution is more. That is, clear image can be possible, even we can differentiate the smaller particles. So this is about the role related to the objective lens in getting the image. And coming to the this is about the how we can get the image. The secondary electron detector detects these electrons, and it will give electrons to the monitor. That conversion takes place in the form of image. That image is used to characterize the nanostructures. And coming to the advantage point of view, different magnification images can be possible in the range like 20 nanometers to the 2 micrometers or the 10 micrometers also possible. Easy to analyze the surface morphology. Sample preparation is not that much difficult as compared to the TEM. High resolution can be possible. In addition to the morphology, elemental analysis also possible. That is, what are the elements present within the sample. That part also we can analyze by using the SEM, applicable to the different fields. Like this SEM is applicable for the material science, biomedical fields, biotechnology, or anything. If you want to see the bacteria, or if you want to see the minute objects, there is a possibility, but except volatile compounds. Disadvantage, it is expensive, vacuum requirements is more, surface information only it gives, not applicable for the volatile or easy oxidizing sample, difficulty in handling. So this is about the advantage and disadvantage. So here I want to show some different, the different image results related to the SEM. This is the graphene oxide, RgO reduced graphene oxide. This is the right zinc oxide material. This is all right like a ferrite material like a rod shape. This is like a hexagonal shape. This is like a biomedical images. So there is a different kinds of images we can obtain by using the SEM. And coming to the EDS point of view, that is elemental composition. So this is like, for example, here it is carbon, it is giving oxygen, cobalt, iron. So this material consists of these four elements. So each and every element, first it understand the primary electron, whatever the electron beam passing through the inside the material, it hit with the innermost electrons, electron will release, and this electron vacancy is filled by the outermost electrons, and it releases the X-rays. These X-rays are used, that is energy is used for unique for different materials. That information is useful to analyze what are the elements present within the sample. Even the color mapping also possible within the total surface, how many how much area it is occupied with the iron, whether it is uniformly distributed or not, that part we can discuss by using the EDS analysis, which is attached pattern related to the SEM. This is the original instrument. So these are the different parts related to the electron gun, EDS thing, secondary electron detector, backscattered electron detector, specimen stage, specimen chamber, like up and down we can move, horizontally we can movable, that is specimen stage, and vertically it can be easily movable. That means there is a possibility to place or focus in a particular area. So it is a movable aperture. This can able to control the intensity of the X-rays, and these are related to the sample stage. So where we are placing this sample stage in the specimen chamber. This is about the general instrument. To understand more, just given the original FESM image to understand more related to the SEM. Finally, the SEM is related to the morphological characterization, relate to the nanostructures. Up to 1 nanometer, we can able to see clearly. So the surface related properties, complete information is given by the SEM, but it is not related to the structural characterization. SEM is takes the secondary electron detector, that is the image can be generated by using the secondary electrons. The high energy electrons focus the surface of the sample and interact with the matter. The interaction gives the different kind of combinations. So in general, we are using the secondary electrons, backscattered electrons, and X-rays to understand the specimen or the sample behavior, surface related properties completely. This is about the SEM, scanning electron microscopy. I hope it is useful to you. If you feel the content is useful to you at any moment, please subscribe the channel. Thank you.